and we will practice a little bit of what we did last time. Okay, Lewis structure for ClF3, monochlorine trifluoride. Okay, so as we're getting into this, ClF3, we would think, okay, these things just have single bonds, which would be correct because all of these elements are halogens. And we would say, okay, here's my stable octet. I'm just warning you, we need to probably count our electrons just to make sure we don't have something weird going on with the expanded octet. So I would fill in all of my valence electrons going around here, and then let's just make sure that we have all of our valence electrons accounted for. So if I've got 4 atoms and they each want 8, that's a total of 32. And then if we have 4 atoms and they each have 7, that's a total then of 28. And that's only 2 bonds. Uh-oh. So something is not right. Something didn't work here. So this is a signal that we have something going on with an expanded octet. Whenever this fails, and you know it fails because we need more than 2 bonds for 3 atoms around it. So let's count. We already said we have 28 valence electrons. So let's make the count here. We have 2, 4, 6. We have 2, 4, 6. We have 2, 4, 6. And then 2, 4, 6 right there. So that's a total of 24. Now we need 2 more for this to get up to the 26. But we have 2 extras. So here is where we have an expanded octet. What this means is that I have 5 ligands. And you're saying, what's a ligand? All right, a ligand. So what it means is I'm going to have these 5 different places where I have bonding occurring. And so that means it goes into an expanded octet region. If you have 5 ligands around it, that means that you are going to need to start talking about this being trigonal bipyramidal. However, that's only if we have 5 atoms around it. I don't have 5 atoms around this molecule. And so what we have to then understand whenever we are drawing this shape is that the equatorial atoms, they are the ones that disappear first. So we would be losing 2 of these atoms here. And so this is what we end up left with. And if we try to then understand that they would be the middle ones that are going on the y-axis, they would be in a straight line. And then I would just have one coming out of the bottom of this one. That one means that this is actually a T-shaped molecule. T-shape is what it looks like. T-shape is the name of that molecule. All right. So a lot of work to get to an expanded octet, but if you have a want minus have math problem and it fails, that's your sign that we've got to do something different. Okay. So circling a ligand, any of these qualify as ligands. Now, an example of a free radical, that would be this location here. That was where we have a free radical. Or if we were to have, say, just 1 electron over here, for some reason it ends up that we just have 1, that would also be a free radical, a place where there can be some bonding that occurs. So if we have an unequal number of electrons, that's a location where there's probably going to be some bonding wanting to occur to try and get itself to the correct stable octet. Okay, this is everything that I wish to share with you today. Thank you very much for staying with me, and I will chat with you again when I get back. I promise I'm back next class. Bye-bye.